Hello everyone. In this video I'd like to show you a new tool which is available in Microscope Image Browser version 2.3, and we made this tool for this tool is designed for 3D linear measurements, and also it can be used to generate and work with various 3D skeletons. The tool is available under the segmentation panel here under this 3D lines menu entry. To start working with the tool, basically what you need to do is just use your mouse clicks. And then what you can see that while you're clicking, the segments, you generate the segments, and then the segments are growing. So this structure that we have here is called as a tree, and it's made of these nodes, which are these yellow points. And these points are connected with lines, which are called edges. So what we can do when we do this, we can generate these trees, and we can also measure the length between the points for each of the trees. Now, if we want another tree, we can also make it. Now, in this case, I have the two separate trees. So to work with these trees, we use as I already mentioned, just mouse clicks. But also, these mouse clicks could be extended with the various key modifiers, such as Shift, Control, and Alt. And depending on what you're particularly doing at each of the model, you can assign various actions to any of these key modifiers. So by default, the single click without any modifiers just extends a tree with the new segment. For example, Shift and mouse click uh, makes a new tree. So if I hold the Shift and use the mouse click, I generate a new tree, and you can see that this tree is shown in a slightly different color. The nodes that made each of the trees are shown in yellow, but there is one special node which is shown in red, and this node is called an active node. And this active node is the point from where the following segment will be drawn. As you can see here, so the new segment was drawn from the previous active point to the point where I clicked. By the way, in any of these states, you can use Ctrl Z to undo the last operation, and you can also go in history, defined number of steps backwards. Okay, so by default, again, the Ctrl click assigns a node as an active node. So, for example, if I move anywhere and hold the Ctrl and do a mouse click, I assign the node which is the closest node to the point where I clicked with the mouse as an active node. And then if I just keep on clicking after that, my trees will be grown from that active node, like this. Let's see what are the other actions. So the next action is called connected node. And okay, if I want, for example, connect this node to this node, if I just use the single mouse click, it just puts a new node like very close to this yellow node of another tree. But if I want to connect this node to this node just to make maybe a loop or maybe connect the trees, then I need to use this connect node option, which I now bound to this Alt click combination. So when I do this, I can see that I made a new segment, and this segment connected for me this node of this tree to another tree, and these two trees are now fused together and shown in the same kind of darker color. By the way, all these colors could also be changed to whatever. You can change the colors for all the nodes, active nodes, and all the segments. Also, we can, for example, make a loop. Like, for example, I want to connect this node to, let's say, this one. So you can see I'm making these loops. I can just connect it to anywhere with this tree. The following action is delete a node. So in this case, again, I will be kind of mounting it for demonstration on this Alt click combination. So, and then wherever I click, it just deletes the the last the node which is the closest to the point where I click, like this. So we also can do insert node after an active node, after the active node. So for example, if I have, let's say, if I assign the active node with the control click, assign active node. So I can, for example, insert another node after this. Oops. Like this. So you can see there was like a segment between these two nodes, and I was inserting the segments after it. If on the other hand I want to add segment here, so then I, for example, click now, then it will add segments between these 2 points. But if I need it to be actually between this point, I need to reassign my active node to this point, and after that click, and then it will uh, add the extra points here. Another action is modify active node. So in this case, wherever I click, now with the Alt click modifier, the active node will be shifted. So you can see here, or for example, we have this very nice node which has multiple connections, and then if I move it, you can see that it kind of recalculates all the connections. For example, we can move it to on the other slice. In this case, we form this kind of very nice 3D structure. Okay, shift click starts a new tree, which I showed, and then one more action which is important is split a tree. So let me show you. For example, I have this tree and I want to split in two. So what I need to do, I need to select the split tree action and delete the node. In this case, the tree will be broken into 2 separate trees. Okay, so these are the actions and then how you can actually add those. But of course, what we need to do, we need to see the actual numbers. And for example, the length of segments, the indices of nodes, and so on. And to do so, we need to open this table view, and it's opened by pressing this button here. Okay, so what you can see here that we have this table with various options. So in the upper part, we have the list of trees. So the trees are individual segments that we have. So let's see, I'll make one more tree here, like at the bottom. So as you can see now that I have now 3 trees. First tree, second tree, and the third tree. And for each tree, I have this list of nodes. So for example, I can have this auto jump, and then when I press, I'll jump to each of these nodes. Or also there are multiple options available through the right mouse click. So for example, okay, I can jump to the node, so it goes into the center. I can, for example, set it as an active node. You see it becomes red. I can rename selected nodes. For example, now all these nodes are called as a node. So I can select them and then I can rename this. Say this is my new tree or something. And then they all will be renamed. Of course, you can also rename individual nodes, like whatever. The nodes. What is important that the nodes are stored in the physical units. So the data set that we have has certain parameters such as pixel size, in this case 14 by 14 by 30 nanometers. And it also has the bounding box information, which is here on the dataset bounding box, which specifies basically location of this dataset in the physical units. So this block, which is shown on the screen, is 4.6 micrometers shifted in the X dimension, about 7 micrometers in the Y dimension, and 4.47 in Z dimension from 0, 0, 0 coordinate in 3D space. And all the coordinates which we can see here, they are in this physical units. And one of these options, we can of course go and see these coordinates in pixels, and then it gives us information that this coordinate, this point occupies, this node number 34, it's in these positions. Okay, when we have these nodes, we can assign them to annotations. So for example, we have this tree and we want to know what are the names of the nodes. So we can select these nodes and then we can make a new annotation from nodes. So what we can use nodes names as this kind of label for annotations or node indices 32, 33, and so on. Let's take indices this time. So what happens that we create annotations. You can see here these numbers, and they're stored uh, in this annotation list. So we have the nodes, and we have their values, and the values are correspond to these. In this particular case, the radius parameter which we have for each of the nodes. There are technically could be multiple these custom fields for the nodes, but by default there is only one field, which is this radius. So if there is a certain number is kind of provided for each of the nodes, so then those numbers will be also be exported as these annotations. And if we want to add like maybe other nodes, for example, from the tree number 3, so we can also do the similar stuff. So I will add to annotations these nodes, use the indices, and then you can see here the indices of the nodes and their values. And we can kind of modify the visualization of these things in the annotation panel. So for example, we might want to see only labels for those. And last option in this nodes table is that we can delete the node, which is the same action as we doing in this 3D lines panel as delete node. In addition to this, we have another table. In this table, menu is called edges. And here, what we see the nodes IDs. We can jump to these nodes. And then it shows the weight, which is the custom parameter. It could be multiple again, but by default there is only one. And then here in the length, it shows the actual distance between the node 18 and 19 as this 1.57 micrometers. So this distance. And with the node, there are less number of actions, so we can just make it jump to the node in this table and make it as an active. um, what else? So when we have trees, each tree should have its own unique name. So we can rename the trees, but each tree should have its own name. Then we can find the tree by node. For example, we want to find which tree has node, let's say 25. And it says that it's the tree number 3, and this is the node 25. Then we can visualize the trees. So for example, we have this fancy tree, which is this one, which I moved away. We can go and visualize this tree in 3D space, and that's you can see here. So we have this kind of structure. Then of course all the nodes could be also visualized, all the trees, and then in this case we just use this button, and then it will show the graph that shows all these nodes in 3D space in the physical units. The nodes can be saved. So if you press save as button here, so we can save it in, let's say, in this default, it calls lines 3D format in the MATLAB. So I can go and save it. Then I can delete all the nodes. And then after that, I can load them back from the file or import from MATLAB. And in this case, it will restore all the structure and we continue. For example, we can check what kind of results we get. So the nodes could be saved and exported, and this can be done by pressing the save button here at the bottom, and we can export them to MATLAB as this kind of lines 3D structure, or we can save them to a file, which is kind of always recommended. So for example, we can save in this line 3D with this line 3D extension in MATLAB format. And then we can, of course, what we can do, we can, if we want to continue with this data later, we can go and load this file back. and then all the structure that we had in that, all the trees and all the points, they will be restored. In addition, it is also possible to save it in the Amira format as a spatial graph object for 3D visualization, or export it in the Microsoft Excel format. And in this case, what we'll get, so this it will be a Excel file, and it will contain two tables, one table for nodes. So it will have information about the tree names, nodes ID, nodes names, tree name, node name, coordinates, and the radius parameter. And the edges will have basically the similar composition where we have nodes that form the edges and their lengths between them, and also this weighting parameter for all the trees. Yep, and then the last button here at the bottom is the visualization settings, where you can specify the colors for all these components, thickness, and parameter which is extra clipping, which means that it will show the lines, the edges will be shown not on the current slice, but also one slice before and after the actual point where they're supposed to be shown. So for example, now they kind of shown on two slices, but if I've put 0 here, then they will be shown only on the slice where they belong to, which is kind of alright, but it's sometimes difficult to see when the actual lines going somewhere in 3D space. You see they look like small dots, and it's easy to kind of to see them if these parameters are slightly bigger. Then we'll see them as kind of lines that they're going somewhere. Okay, so like for example, if I have this data set of trypanosoma and I want to start, I'll start putting the points, and then for example to segment this mitochondria, see where it goes, like this. Then I can go back to the point when they, for example, split, assign this as an active mode, and continue it, for example, to this direction. Then I can return back, maybe here, put another node, and let's see where it goes here. Here it's probably splits, yes. Continues further, and to here, and so on. So I can make skeletons using this tool, and then I can go and visualize these skeletons in 3D. So these are the points that I placed, and then we can see how mitochondria is look in 3D space. Okay, I think that's it for now with this tool, and I hope it will be useful for some of the things. Okay, thank you very much for attention.